Good afternoon, everybody. First of all, I thank you for ICN giving me the opportunity to talk about something which is pretty important in the recent times, especially on the electric vehicles and battery materials. So I will talk about one of the battery material, that's the lithium. It's one of the critical component of battery materials, and it goes the lithium story. Before I start talking about lithium, I just wanted to tell you a small story about lithium. I mean, on the right side, you see a pretty familiar picture. That's 7 Up. But do you aware what is the 7 Up brand name came up? How it came up? Okay, the story goes like that. In 1930s, there was a great depression. People, you know, in the stock market, they lost money, they lost job. So people were depressed. And at that time, the cola company came up with a new idea. So what they did actually, they used a material which actually acts as a mood enhancer or an antidepressant, and that material molecular weight is 7. And once you have that material, in your cola, because it's an antidepressant, it keeps your mood up. And that is why it is called 7 up. And that particular material is lithium. So the use of lithium in 1930s goes back as a mood stabilizing drug. It's still used as a drug, but you are no longer find lithium now in the 7 Up uh, drink, because in late 1940s or 50s, US FDA realized it's not really a cola, but it's a drug being used in the cola. So they have banned use of lithium in that cola, but the brand name still continues as 7 Up. Those days they used different salts of lithium, be it lithium citrate or carbonate, and that acts as a mood stabilizing drug. And it is the oldest use, and that's for since 19th century. Later on, I will tell you how the lithium actually evolved and revolved, and what exactly the past happened and what's current, what's in the future. So in 20th century till last decade, the usage of lithium is mostly as a agent for the chemical synthesis. They used raw material to manufacture a lot of life-saving drugs. Then they use as a catalyst initiator for polymers. And it's a very versatile compound. Lithium compounds is very versatile. They have very good selectivity, and they have very wide application. So till 2020, I would say these are the major applications of lithium derivatives. But what exactly happening today? Nowadays, actually, everybody must be talking about electric vehicle, and the major application of lithium now from a drug or from a chemical synthesis meant for polymer tires shifted to more of a energy store ingredient. So that's a lithium for you. Now let's see what exactly is lithium. Lithium is the lightest metal and is a solid element. It's the lightest solid element metal. It's a highly reactive. You do not find the lithium metal in a free form. Whatever lithium you found, you'll find either as a different composition of salt or a complex salt or something like that. But the free form of lithium is not available. It's found in earth elemental form, and the biggest advantage of lithium is its highest charge density and heat capacity, and that is why it is most preferred element of for the battery application. I'll go to on that part later. And people nowadays always talks about lithium, 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 but actually the lithium is used as for different salts like lithium carbonate, lithium hydroxide, bitter lithium, or some other things. But generally they talk about only lithium. So it's a very broad term for the convenience. But generally we always talk about lithium LCE, that is lithium carbonate equivalent. This is a very important slide. Basically, I just wanted to familiarize what exactly lithium is, where exactly it comes from. As I earlier said, lithium doesn't available as a free form. It's available as a you know different salts or something. Okay, so the major if you look at the top one for the Earth's crust in terms of ppm, you could see sodium, magnesium, potassium are about 1,000 times more than the lithium. So in Earth's crust, the amount of lithium presence is about 17 ppm. Then comes the hard rock. That's spodumene, one of the biggest resource for the lithium, which generally contains about 8% as a lithium oxide. Then the next source is actually brines. Brines is basically, it's basically a salar concentrated water where exactly you find the presence of lithium is much more little concentrated than the conventional one. Classical example, I mean, continental brine, the lithium presence could be about 200 to 2000 ppm. In geothermal, it is up to 400 ppm. Oil field, it is about 700. And our normal water, including the seawater, it contains about zero point 0.1 to zero point 0.2 ppm. So remember how exactly we extract and get lithium. It's very interesting. Basically, we have to mine lithium from those brines or the hard rock, then take out from the ppm level with using a different technology. I will not really talk about how exactly it's mined because the time is limited. Else I would have spoken in detail how exactly it's being mined. But the commercial application as of right now, uh, till 20 till end of last century, the commercial application was always from the spodumene. But extracting lithium spodumene is a little expensive compared to the brines, and that is why we, along with other lithium supplier, moved to the continental brine, and the continental brine actually you will see in South America. In South America, especially on the Andes, the lakes in Andes contains about, depending on the location, whether it's on the Chile, whether it's on the Argentina side, or whether it's on the Bolivia side, the same lake, depending on the location, as I said, contains a different proportion of lithium concentrated, and from that exactly we and other to take out the lithium as a lithium chloride or carbonate, and then they convert into different lithium compounds. As I said earlier, I mean, today or future application is actually, lithium is actually used as a future, energy storage. And the major application as far as energy storage is concerned is called electric vehicles. And electric vehicles, about a decade back, it used to be considered a very different technology. People are not really aware what exactly is the future. Skeptics said, no, 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 no. Hardly, there will be any electric vehicle in the road when you talk about in 2010 or 2008. Remember, we are working on this specific application as a company since 2005 or seven, I would say. And at that time, electric vehicle was something relatively unknown, very new, nothing heard of, and people are really skeptical understanding that technology. And when the new technology comes, I mean, I just try to quote few things for you. How exactly, people generally, when a particular new technology, before becoming a mainstream, they tend to think about new technology. Classical example, you know, before the aeroplane thing started, people are saying heavier than air flying machine are impossible. But the aeroplane is heavier than air, and that's a possible, right? Similarly, the computers in 1950s, 1960s, nobody was what exactly the use. Skeptical say, oh, it's not really something people will think about it. And now look at after 40, 50 years, it's everybody's part of their life. So at that time, the classic quote goes with Miss Watson, the then chairman of IBM. I think there is a world market for maybe 5 computers. And look at today, what's going on. Similarly, I will go to the mobile devices. A long time back, when the cell phone came into the picture, say in late 90s, people were wondering what exactly the mobile phone, how much it will be used for. I mean, will people willing to accept it as a device? And at that time, AT&T, they it's happened 109 million subscribers. So from this, it's very clear that it's very difficult to predict a new technology, but eventually the technology evolves, then it becomes sometime mainstream, and when it becomes mainstream, it becomes too big. So that's the moral of the story, even for the electric vehicles. This is a very busy slide. I will not really talk about much of a thing on this, but as you know, Tesla was a pioneer for electric vehicle. They popularized the electric vehicle about a decade back. At that time, probably there was the only one company who was in electric vehicle. Now, I mean, in 2020. Now there will be investment of more than $500 billion just in EV. That's a huge number. Earlier, hardly there was anything. But look at this thing, the way these things are moving, and I will go to next. I know one more slide where I will talk about what could be the number of vehicles, what is the projections and all, and that's really something to people will understand how things are changing and how quickly things are changing. I'm sorry, I hope I'm on time. It's 57. Oh my God. Okay, so this is the recent trends in the EV cells. I'm sorry, this is a busy slide. I will just go through this quickly. Just look at in 2021. We have done 3 parts based on the different governments, what they have said, what they are placing, and we have an place for a zero emission by 2050. So if we consider all the 3 scenarios, look at in 2021, as for the policies, stated policy means we have already individual governments of its country, they have already passed the rule, a law and regulation. And when we say announced place, it is just announced, but not yet part of a really a regulation till date. And the zero emission is by 2050. This is a scenario. So look at the scenario by 2021, when is the stated policies, we have hardly about 20 million vehicles, electric vehicles. but that could project it to jump into about 200 million. And for the announced part, it could jump into about a little more than 270. And if we consider the net zero emission, it will go beyond 350. So just imagine 20 million to 350 million in a decade. That's a 10 times. So that's the EV trains happening, and I have included every possible EV vehicle in this chart to further to believe that it's how things are moving. And just look at it, 2015 probably we'll have less than 60 different models, but by 2021 we have almost 450 models, and now each and every company trying to come up with new models. There's some lot of models will be now coming. It will be introduced, and every year we are seeing the number of launches as growing up, and by 2021 it's a 450, and by 2030 you never know. I mean, this could go beyond 1,000, 2,000. You know, So that was electric vehicle story. Now, I will come go quickly on the segmentation on the battery chemistry. I will just talk about the secondary battery, the primary battery. Everybody is aware. The secondary battery is earlier, nickel metal hydride. Then come the lithium, and I mean nickel cadmium is already there. Lead acid is the oldest one. So I will concentrate more on a lithium ion here. This is a pretty busy slide. I will go through quickly. The battery market was around 80 billion dollars in 2016. It's growing rapidly at 11% of CAGR, and in 2021 it's estimated to be 131 billion, and it is being projected it will grow more than a double digit. I mean, it's more than 11% CAGR now for the for 21 to 30. Yes, I mean that why it's going I mean increasing in such a rapid pace. I mean, I'll just quickly couple of points will be there. People are moving to alternative energy, renewable energy, and all. That's one drive. Second is population is increasing. People are buying more automotive, and the third one is, yes, the biggest one is the climate change factor, and that particularly dictates that eventually the traditional fossil fuels will be replaced by the so-called renewable. And I think most of the countries have placed by 2035 or by 2050 the fossil fuels will be replaced. I will now skip this one because I'm running out of time. Okay, so I mean, look at this lithium-ion battery market focus. I mean, in 2020, in terms of megawatt hour, it was hardly anything. It reached about 250 gigawatt in 2020, and it's being projected to reach more than 250 trillion gigawatt hour by 2030. And look at on the right side how the industry is going. I mean, electronic devices has almost peaked, just about 3%. Look at the electric vehicles like auto e-buses is about 23%, and others are growing at 11%. I mean, this part I will just go through quickly. By 2020, as I said, it's about 250 gigawatt hour. The biggest contribution comes from the China buses and all the things. In 2030, I mean, still the electric vehicles will be the biggest driver. And look at the way the things looks. China will be the biggest growth factor for the battery markets. Here, let's talk about lithium-ion battery value chain. How exactly the value chain happens. I think you probably can see this with this one. Uh, the starting materials is actually different metals. Then it goes for the processing to manufacturing cathode anode electrolytes. Then goes to manufacturing battery cells, then battery packs, then individual applications. So if you look at what exactly is happening in the value chain, as of now, China is actually the biggest player. I mean, they almost contribute about 80% of the total global market, and they will continue for some years in the future as well. European Union is now getting up a little bit for that, and I think by 2025 they will have some substantial capacity in those value chain. But look at certain points like graphite. Still, China is 100% in terms of production. See, look at the cathode material. They are still at 80%. Anode material, they're still 89%. So basically, it's a China, Japan, and Korea. This a three Asian giant almost controls right now about 100% the battery value chain. But yes, Europe is getting up for that, and the US is also getting up for that. Now, now I will talk about a little more. I spoke about the various different lithium battery technologies. I will quickly go through what exactly is happening, is currently happening, and what exactly in the future, say next decade, for the lithium ion battery, and especially this is a reference with context in India. Because in India, see, right now, if you talk about the biggest battery application is NMC application. Like for the NMC, we really do not have a cobalt, we do not have a nickel, we do not have lithium. So literally, if India wants to be a bigger player in the global scenario, we have to import all the three, and that's not a good situation for us. So basically, we wanted to have some technology where we did not really import the different different metals for the as battery ingredients, and that is why the technology is actually evolving right now. And let's touch on that. Lithium ion is already there in the market. Earlier, it used to be about $1,000 a kilowatt hour. Now the prices has almost dropped to 100. Depending on which actually which cathode anode or electrolyte used, it's almost dropped to less than 100 to 200. The next immediate will be the advanced lithium ion. Basically, this will be where there will be a little bit of changes, improvements in the cathode anode or electrolyte material. Classical example NMC 811, which is instead of 522, and similarly LFP. Now, just a couple of days back, CATL has announced they have found something called instead of lithium iron phosphate, lithium manganese iron phosphate. Just addition of manganese, they said it will be about 20% of higher electron density. So that could be a part of that. The advanced lithium ion. The future technology will be, I do not want to, I'm sorry, I'm running out of time, so I'll be a little quicker on this. The future one would be zinc air, then no, lithium sulfur, the solid state battery, then flow batteries. Here we have actually mentioned their cost, energy density, and the life cycle. These are the three critical elements. When you choose a battery, remember the cost is important, then in energy density in terms of watt hour per kilogram of the battery, then the life cycle. Life cycle means how much charging discharge it can take. That is very important. Why lithium-ion battery is currently being used widely, because certain battery packs you can charge and recharge up to 5,000. So the life is about 5,000 cycles. But if you look at the new future technology, they are not that in terms of either your energy density or in the life cycle, they are not really comparable to lithium ion or advanced lithium. But the researchers are working on it. They are coming up with a new novel compounds, and we believe things will change rapidly, especially for Indian, especially for India. You know, uh, 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 these two are actually challenging for India because we really do not have those key raw materials available in India. So this is the futuristic technology. I mean, this is the best one. I mean, for the Indian perspective, the sodium ion. And recently, I mean, last year, even Reliance has announced they will be spending about $2.5 billion on this technology. And if that happens, it will be really, possibly it will be a global trendsetter because the kind of material used in the sodium ion battery compared to the lithium ion battery, everything in Indian perspective, you will get everything available within India, and India need not import, anything. So it's a as of now, it looks like the best future technology for next 5 to 10 years for India. But at the end of the day, the energy density is still very low. I think probably somebody should work, that goes beyond the 200. And if that happens, this can catch up very quickly. But remember, a lot of things are happening very quickly. Every weekly or monthly, there are new patents, new announcements, or developments are coming in. So you never be surprised to see something, a very information, something, development of technology where certain those parameters could be improved. So that's sodium ion, then lithium carbon. Semi-solid is also, I mean, solid state battery, and the later on semi-solid batteries also people are working on it. But these are actually futuristic technology. We could be we're talking about 2025 or beyond that. So these are the part I really spoke about. That's the whole thing about lithium chemistry in the battery. I have not really spoken about other battery materials. This is only a part of lithium I have covered. So with this, I will just conclude my presentation. Should you have any question or something, do that.